Hello, and welcome to Emacs Advanced Tips and Tricks. My name is Caleb Ayew-ew, and I am a principal developer at Configura. I've been programming in CM for over a decade, and I've been using Emacs for even longer than that. The goal of this presentation is to demonstrate some advanced ways of working within Emacs and hopefully give some inspiration on how you can improve your workflow using the extensible tools and customizations within this platform. We are not going to be building a theme in this one. So if that is what you're after, you could check out the COVID era Emacs presentation I gave on Configura's YouTube channel. The first theme we will cover is enhancement, where I will focus on how to customize and improve Emacs behaviors to your liking. Then exploration, where I will discuss ways to navigate Emacs itself and use Emacs to navigate other things. Followed by efficiency. Here I will talk about improving developer workflow and extrapolation. And this theme focuses on tying things back into the CET developer ecosystem. Enhancements. There have probably been a few times where you've said to yourself or even out loud, I really wish Emacs could do X. Well, there's probably a package that does that. In the ELPA or MELPA repos. ELPA is the Emacs Lisp package archive. It is the official GNU or GNU maintained repository for Emacs Lisp packages. It serves as the primary source for packages distributed alongside Emacs itself. It aims to simplify the process of installing, upgrading, and managing these packages, which extend Emacs's functionality beyond its core features. This is the link here. There's also, alongside that, the non-GNU or non-GNU maintained repository, which is integrated into the default packages list since Emacs 28. And in addition to that, there is MELPA, which is a community-driven repository of Emacs Lisp packages. This provides a broader selection than ELPA does, and it's become a widely used resource for extending Emacs. Like ELPA, it's accessible by adding its URL to the package archives list in your Emacs configuration. And MELPA is commonly accessed through melpa.org/packages. And there's also a stable repository as well. While the stable repository aims to provide more vetted packages, it tends to lag behind due to the main repository in terms of how it gets updated by the developers of those packages. Thus, it's results in fewer available packages on the stable. Some security concerns regarding MELPA explicitly. It is a community maintained and not directly vetted by GNU project. So it could pose some potential security risks. So packages can be submitted by anyone, and there are moderation efforts of this repository. But at the end of the day, those are just people, and it's kind of up to you to ensure that anything you install from the MELPA repository is up to snuff. And as far as I know, the verification process is one and done, but it is community driven. So if there is anything on there, it's likely going to be community vetted over time. But like I said, it's kind of up to you to ensure that what you're installing is kosher with how you are structuring your software within your organization. That being said, yeah, use under your own discretion. So since Emacs 24, the ELPA repository was the default packages list, and then the integration of the non-GNU repository into the default packages began in Emacs 28. MELPA will require explicit configuration within your .emacs or your init EL file, and it is not included by default. So let's take a look on how you can set that up real quick. On the screen, we have a Emacs settings file that is a condensed version of what I use. And I will distribute this out to everyone here. What we have in front of you, these commented outlines of code, will include the MELPA or the stable version, if you so desire, to the variable package archives. I created this little function that inserts into the active buffer a variable and its value. You can see right now the variable package archives is only pointing at the new and non-new repositories. If we were to list the packages out, call Emacs Lisp packages, this will show you all of the available packages that you can download and use within your Emacs. And all of these are offered by the new foundation. So there's a lot, as you can see. So I'm scrolling down to the packages I currently have installed, which isn't too many. You can see some are built in, but you can simply click on one of these, or if you're mouse adverse like me, you can select it with your cursor and just hit enter, and that'll bring up this information buffer window. And if I were to hit enter on this, it's going to ask, yeah, do you want to install this, yes or no? And it will contact that repository that it is in and install it. So now I have a YAML mode, or YAML parser rather, installed for my Emacs. And likewise, if you no longer need it, you can go here, click on the delete, answer yes, and it will delete it for you. So if we wanted to add in the MELPA repositories, you can press Q, and if you uncomment this and restart Emacs, it will load it in, but you can also do Control X, Control E to evaluate the Lisp code here. And if I run that insert variable again, package archives, you can now see it has the MELPA included. And if I list my packages again, you now get a lot more options to choose from. So next we have customization. What I mean by that is the Emacs command meta-x customize. This can allow you to modify session variables, save them into your Emacs through a pretty good interface within Emacs itself. So we're back in the Emacs settings file that I have available. Within here, or anywhere really within Emacs, you have the ability to customize using the command meta-x customize, and then let's do variable. So using the package archives that we talked about earlier, if we press enter, you can see now that it houses all of the URLs and the archive names that we set up. Within this interface, you can add new ones, delete, and so on, just by clicking on the buttons here. So there's a nice customization interface to do these sorts of customizations to any package. So if I were to delete the MELPA from the package archives variable, I can go up here and click apply and save, or I can save it just, as normal with Control X, Control S. Then if I collapse this, you can see that this is just the variable here. Now, this is part of a customization group called package, and you can get to that by customize group, and I can type in package, and it will list out for you all of the variables that are marked for customization within that particular package group. Some of them, like package, have subgroups as well that you can dive into. And you can go to its parent group, which will take a second. It'll list out all of its subgroups. And if we go to the main customization, which is Emacs, we'll list all of the available areas. You'll notice that we have CM here, and there are some CM level custom variables that can be edited as well. So now we have customization under our belts. Next, we have this question of, well, what do I need to do if it goes beyond these customizable variables for a given package? That's where this advice comes in. So what do you do when you want to influence someone without commanding them to do something? Well, you would give them advice. Emacs has advice EL. This is a powerful feature that allows you to modify the behavior of existing functions without directly changing or overriding their original source code. And it's incredibly useful for extending functionality. You can add new capabilities to existing functions. It's good for debugging. You can log function calls, you can inspect arguments, or even temporarily disable functionality. And you can customize it even further. All right, this next example, I'm going to demonstrate how you can use advice. So we'll start with a clean slate in an empty file. I've named it adding. First thing we do is require advice. And then this is kind of a habit of mine where I set up a local variable with a new buffer that I can, let's call it adding output, that I can insert anything that I want into it from any of my list files. So we'll call it adding output, split that, and say, let's switch to adding output. All right. And then just to try it out, test, xbuff, evaluate. You can see down here it adds it in. So let's make a function. We'll call it a real good add, and it takes in two parameters, x and y. Put a doc string in, adding is fun. Make it interactive. We'll take a number and another number. Then we will print the result into our new buffer. We'll give it a timestamp. Why not? So timestamp, and this will be argument 1 plus argument 2 equals the result. And first one is format time string, and we'll do year, month, day, and hour, minute, and seconds. So that's our time string, argument 1, argument 2, and here we'll introduce a bug. So Emacs is prefix notation, and what that means is this plus sign is as if you wrote out x plus y plus 2. So there's the bug, and that is our entire string, and we will put it into our xbuff variable. Control X, Control E will give us the evaluate this function, and then we can call it interactively. So number 1 down in the mini buffer, number 2, let's say 3, and oops, got a bug there. Try that again, 2, 3. You can see our timestamp 2 plus 3 is 7. Not exactly what you would want in an adding function. So this is where advice would come in. Now, if you had control over this, obviously you could just edit it yourself, but what if you didn't? Let's try some advice. So let's make a new function, a better add before. Before is essentially a hook that gets run before any function is called. So we'll give it another doc string, the advice function to run before a real good add. And then we will do a print format /n, the following result is false. The correct sum is, and we will do plus xy, and send that into our xbuff. So now we have that function defined. You can add advice with advice add. Give the better add before function name. And this is the decorator before. And this is the better add before. I actually messed that up. This is the function you want to advise. Real good add. Okay. And conversely, you can remove, advice remove, give the function name and the introduced function name. So if I evaluate this, now we have some advice given to a real good add. Let's try that out. Real good add 2 and 3. And you'll see that our output tells us it's wrong. Now, this doesn't actually solve the problem. You can also do a after. After, and we'll update this a little bit. The previous result is false. The correct sum is this. So if we remove a real good add, say after, after, after. Okay. We'll evaluate that, add that, and let's slash in here just so it kind of breaks it up a bit. Now, I reevaluated this so it wouldn't need to be re-added as it's already added. So let's do 2, 3, and we can see here the previous result is false. This also doesn't solve the problem. So we could intercept the arguments with an arounds decorator. So let's rename this to around. And what is different about that is we can take in the arguments of the original function. We'll get the original function name, and the rest of the arguments will get thrown to the list. Run around. So this will be a bit different. We will edit the arguments that we pass into a real good add. So let me finish that up real quick, and then we'll get to the guts of that. Round. So let's go. This should fix it. Print. Let's do. Actually, we don't need to do a print here, so we can just apply. Use the original function, and we will add to the first of the list of arguments a -2, and I missed a parenthesis there, and we will also pass in the remainder of the arguments. So it's a bit of a hack to get that going, but that should work. If we add this, now let's call this again. Let's do 2 and 3. Notice that my argument is 0 plus 3, but the answer is correct. So this still doesn't fix the problem because the sum is now correct, but the output is incorrect. So we can go even further and just simply override completely the function. So we'll call this a better add override. The override takes the original parameters as well. And what we can do is just simply grab that, remove this, define that, evaluate it, and then let's do override, override, override. So we'll add it, make sure we remove the around, and now when we call this, let's do 2 and 3 again. You can see, oops. Oh, yeah, it's inserting above. Yeah, this was down here. And that's why we did the timestamps, because it will insert where my cursor is. If we do 2 and 3, yeah, now it looks fixed. There's a few other decorators that are possible here. I won't go into them. So moving on to exploration, it's not about simply finding things, but understanding how to find things. Um, and here we'll discuss a lot of tools to navigate through Emacs and use Emacs itself to navigate through other things. And I've divided them into two categories, the first being inside Emacs. So first, inside in Emacs, describe everything. The describe function within Emacs can extend to so many different objects. It's kind of like an Emacs verb that you can utilize to investigate almost every aspect of really any element within Emacs. So there is a describe function, which is under the help F, or you can do a meta X describe function. That's the method name. And there's a describe key also within the help. You can control it K or meta X describe key. And what that will do is give you the information about those particular elements. You can use describe to describe face. You can describe lists. So there's a lot of things that you can describe from the Emacs point of view. So if we take a look back at our really good add function, if we do meta X describe function, it's going to autocomplete what your cursor is on. If it's already a function, you can type in, whatever you want in there. But if you don't type anything, it'll autocomplete to what your cursor is on. You notice that it'll open up this information down at the bottom. And this is the function description. We have our doc screen here, and it also lets us know that there is a function advice with the override decorator, which we set up earlier. So if we add in the before advice, I just evaluated that. Just go back in here and refresh it. And it tells you that it has before advice as well. You can actually add all of the advices. It tells you that they all exist within here. You can step through the different help buffers that you have available until it gets to the point where you don't have any more. But you can always hit Q and exit out. So that's pretty useful. Describe this function. Okay. So I do describe function one more time. And let's say we were interested in what C mode did. This is a bit more verbose. It talks about the key bindings. And it will tell you where the function is defined. You can click enter on that, and it will open it up for you. This is the source code. If you don't have the Emacs source code, I would recommend having it, downloading it, and then you can look at how different things are done. And then each of these are clickable elements. In the same way, you can inspect variables.
like this, a brief mode. So if we do describe variable.
Next is the apropos function. This is also within the help. You do Control-H question mark and then A, and this allows you to search for functions and variables and commands, modes, and this is if you have some sort of inkling of what it might be called.
Control-H and A. This is the apropos command. I type in describe. Let's expand this out. There's a bunch of different functions around with the describe prefix.
Now, this is also inside of Emacs grep. If you do tag searching or find in files through the CT operator, grep can actually be more beneficial, in my opinion. This one is built in, and it can save so much time searching for code. I have it set up to look in the CM and RS files by default, and I'll demo that in a sec. But typically, you can look through EL and XML. You can do all sorts of things with grep inside of Emacs, and utilizing the customize, you can set it up to whatever default command that you would like. And I will show that now. Grep is a built-in function within Emacs. If we go to the describe function, and we'll type in grep, you can see that it can be run interactively, either through the window, like the context menu with your mouse, or you can do metax grep. It'll open up the mini buffer down there, and this is the default behavior. Let's go to the CM geometry box, CM. So let's look for all instances of the word shrink. Okay. So let's open up grep, put a space, shrink, star, and let's see what we get. You'll notice that there's some stuff in here that's kind of weird. If you don't know what's going on, this isn't information that we necessarily even want to worry about within tags. It's telling us it's found directories, which probably don't really matter. We're just wanting to look in files. So you can customize grep, and we can set it up in such a way. Sorry, I put grep instead of group. Customize group. We can customize it in such a way that is more beneficial to development within CM. And I'm going to alter this here. So the first thing that we can do is let's do case insensitive. Actually, we'll do recursive, and then we'll put case insensitive on the end. Back on that in a second. And then let's include CM and RS files. And then let's put a space after, so then we can just start typing when we want to start searching. So customize group, I can save that, yes. Let's do something real quick. Did you know Emacs has tabs? So I can actually click that. Now we have a new tab. A Control tab and Control Shift tab will cycle through. And let's go back to our box.
And let's open up a new buffer. We'll point it back to the grep results that we had earlier. And let's do that grep command again. Now we have a more interesting default. And if I wanted to look for shrink, again, star any. You'll notice though at the end there's still that null. We can also get rid of that. If we go to the null, use the null device value. We can append null device. It's on by default, and that's what is appending that null to the end of our command here. We don't need it because the grep tool that we have installed with CM Emacs has support for that -h. So let's set that to do not append. We'll save that. Oh, yes, yes. And go back to our box. Grep one more time. And now we have all instances within directories and subdirectories of geometry of the word shrink. We can also do it without the star now. It'll give the same results. What's more is that these results are put onto the error stack, like the CM errors that we have when your compiler throws a warning or actual crash with the stack trace. These are steppable through next error and previous error. That being said, because the CM layer takes those commands and uses them for the CM errors, you'll need to rebind them if you want to use keyboard commands. And I'd recommend using similar commands. So you just kind of have to switch how you think about it. But I have mine set up to Alt capital N and Control Alt capital N. And what that allows me to do is step through each instance of the pattern that we find. So you can see that grep is quite handy. And in my personal layout of windows within Emacs, I usually have a grep buffer just always open. It's interactable too with a mouse, so you can go in here and click, or if you have Acelinks installed, I should find that, but you can easily jump to one of interest. There is also rgrep. If you don't want to go through the process of setting up default commands, this is what I would recommend. It differs slightly because it uses find and then greps the results of find. Now on to the outside of Emacs, and this is a caveat of maybe outside of Emacs, because if you didn't know, Emacs actually has a built-in web browser called Emacs Web Browser, and you can launch the command with metax eww. We could go to the website using web browser, but let's actually use the built-in web browser that is within Emacs. You can launch it by eww. And let's go to jolly.org. Okay. So now I am browsing the web. If we go to info rather not org, we can go to his Emacs blog. And if you have Acelink, you can hit, oh, it actually works within the world wide web browser. I didn't name it just by default. So let's look at what would be interesting. Let's do autoload. What does it say about autoload? autoload describes the autoload function. Now, this is text-based, so it's not going to give you a super robust web browsing experience. Let's go back. So, for instance, our search here, let's search for variables. Doesn't seem like it works, right? And that's actually correct, because it is the ampersand key. So this is what it looks like, search. And so let's do functions. Yep. So that's why it doesn't work within the web browser, is because it uses some sort of pagination. So, but it's pretty easy to navigate through, and then with things like Acelink, you can go quick if you have a website that has mostly text-based content. So, and with the tab mode, you can even just keep it open. And switch between. All right, so now we're going to get into a little bit about efficiency. First up is organization. And organization, you can't talk about organization without the org mode omnibus. And I'm sure we've all heard of org mode, so I'm not going to spend too much time talking about it. And I know one of the other presentations that we have it goes over some of this in more detail. I'm simply just going to show a little bit about how you can use it to set up a to-do list and an agenda. But yeah, the org mode is pretty extensive. It could be its own presentation by itself, but you know, the possibilities of this mode are seemingly endless. It can be used for task management and project organization. I mean, you could even do like code integration with snippets. Yeah, you can use it as like even a second brain, like a note-taking tool. So there's a lot of stuff that you can do with it. So let me just show real quick what that is going to look like. Let's start a new org file. First, I'll go back into my profile, drop back here, and let's do, let's say a blank.org file, make that. And now it is, you can see it is in org mode, describe mode. We are now in an org mode setting. So let's do something here. Let's start by adding in a date. Okay, so now we have a date, and save it. And what we want to do is bring this file into the org mode agenda files location. So there's two ways we can do that. There is a key command that runs this function, which is org agenda file file to front. And if I pull this up, you can see in the auto completions here, it's bound to Control C left bracket. And what this will do is include any of the files that we have marked in the variable. So Christmas group org, go to the agenda. It will include it here. So let's refresh this. There we go. I actually didn't run the file. So I'll go org agenda. Files, where's that? There we go. So you can see it now includes blank and to do. And then what that means for us is when we run org agenda, let's say, what is it? Let's do N for agenda and all to-dos. You can see that my agenda view on this bottom window has my blank entry. Okay, and all of my to-do list items, which are none right now. So that's kind of cool. We can do a little bit more sophisticated thing with it by putting in a description. So I'll say I had a meeting and I knew its date and time. So let's say it's on the 4th at, let's say, noon. Okay, save that. Go in here, and you can run that org agenda again, or just press G in this buffer. And, whoops. There we go. And you can see now that I have a meeting at noon on Saturday. There is a key command for the scheduled as well. You can do Control-C, Control-S, and you can pick a date. Say, I don't know, 17. I'll change it for you. Or if you wanted a new one, you can do 5-10-3. Save it, refresh this with G, and yeah, now you see that it is updated here. Another thing that we can do is to do, and this will appear in the global to-do list. Let's Control Enter. There we go. And indent with Alt Shift arrow. Create subtasks in to-do list. Save this out, refresh the buffer, and you can see that I have an entire list of things now that I need to accomplish. And these can also have due dates scheduled by and so on. So this is just kind of touching the surface of just agendas in general and using org mode to set that up. Yes, and tab bar mode. I mentioned this in one of the demos. Emacs introduced tabs. It just helps break apart different groups of information. So what I like to do is have my CM in one area and
anything else like web browsing or helps in a separate area. This is something that I do almost every day. I come across some things that I need to change within like a CM code that is very patternistic, and I use a custom defined macro. This is actually the M in Emacs. So let me show you real quick on how to do that. If we go back, we'll quit that and go to let's go back to our adding EL. Now, the way that we structure this when we first set this up is we define the function, added the add function, like call to advice add, and then advice remove. What if we wanted to restructure this in a better way? Like say, put all of our adds down at the bottom and then removes underneath that. We can do that pretty quickly with macros. X open parenthesis, so left parenthesis, and you see in the menu buffer it says now defining, it doesn't say now, but defining KBD macro. So the first thing is to make note of where your cursor is, and we can go advice add, mark and select all of that, cut, kill the line, Control K, press end to go to the end of the file, and then press yank, Control Y, then with Control U, Control space. We'll do that a couple times to get back to where we were. And then let's search for the next one. Advice add, and then remembering where we had our cursor to start, it was at the front of the line. So press Alt M to then jump to the front of the line. And now we have a macro. To stop recording, do Control X, close parenthesis, and the menu buffer will say keyboard macro defined. Now we can execute this macro again and again. So we have 3 more advice adds. We do Control X, E, it'll run it. It'll run it. You just press E again after each one, and then press E. So now we have all of them moved to the bottom of the file without having to manually do it more than once. And if you recorded it correctly, it will work. So add advice. So now we can have this here. So we can do that again for that advice remove. So open parentheses, Control X, open parentheses. We're again on the start. So this time I'm going to do a Control K, press end, press enter, Control Y, and then Control U, Control space a couple times to get back to where we were, and then search for advice remove, and back to the start of the line. And then there we go. So this is nice if you find some things that you're doing over and over and over again in a very repeatable way. You can actually even save these if you do a certain thing a lot. And that can be accomplished by, so the most recently defined one, you can give it a name and then you can insert it as code. So if I split that and I go back into my adding EL, so Control X, K, N, oops, X, Control K, N. The last macro was advice removal macro. You don't want to override an existing function name. And then you can insert it with insert
kbd macro. And if you press Alt-P, it'll give you the last thing you typed in. So you can see that is just key commands saved as a alias in this case. You could take that as well and create your own key bindings, and that's exactly what I do here with this. This is kind of a gross little hack that I have that allows me to inspect and change buffers at the same time. And one more, just little minor note is revocation. How do I undo something that I did in the past, or maybe I deleted some information that I now want back again? And you can actually inspect the variable that houses all of the information that you cut away in the kill ring. So let's show that. Like I said, if you have deleted something in the past that you're like, oh crap, I need that back, the kill ring is the name of the variable where everything goes to die. So if we inspect that, let's close that out. You can see everything within here between the fontified and stirs is things that I've deleted. It has those advice. If I go to the end, you can see I cut an entire function and moved it around. So there's a lot of old information within the kill ring that you can sift through if you needed something out of it. You can even customize this variable. Well, you can customize its length. So if we do customize group killing, so the kill ring max is an integer, so number of elements within the kill ring before it starts deleting them forever. So by now I feel like I've given quite a bit of information around different areas within Emacs itself and how you can improve your workflow and things like that. But how does it tie back to your day-to-day CM development? So let's talk about extrapolation. How does this apply to you, and how can we take this knowledge and extrapolate it further? So within CM, maybe you saw this in the initial demo of how to get custom packages, but this is a pretty nice package that I've been using since it was released. It's Jira. It has a Jira integration right within Emacs, and I will demo that. It is in the NonGNU repository, so we can list those packages again. We go to the bottom and we'll search for it. It is Jira. It's an interface to Jira right within Emacs. It's been super handy. Let's kind of show you the interface right now. Jira issues. I can look at my filter. It's saying developer support and not closed right now. And that's this guy. Here we go. So this is what it looks like here. You can even edit the ticket directly if you have the right permissions, obviously. You can look at, you can change the issue status. You can open the issue in the web browser, navigate to its parent, add watchers. Yeah, you can do all sorts of things right through here. And one of the things that I really like is you have the ability to also add in a work log. You can add the time spent right from Emacs.
How can you invoke CM code directly from Emacs? And I'll talk a little bit about this in this next demo as well, leveraging the power of your profile to do your own custom commands.
If I go to my abridged one, no source. So there is an Emacs command within the CM repository. We can actually describe it. Describe function and CMEL. So here it is. What this will do is take in a string of CM code and run it. And within my profile, I have these two key bindings for rebuilding snappers and rebuilding toolboxes. That's what these functions do here. Now, we can take this further and define our own custom functions within our profile and link it to that. So if I go back to this, back, and let's go to new test. So I've created this function, new test zoom. It opens a new test. It runs this function, which creates a DWG origin snapper, and it places it at drawing origin, and it zooms out silently. And then if I go back into my Emacs settings, let's go for that guy. We can use the CM compilation no source to then call it from your profile. The sky really is the limit here with what you can execute CM-wise from, directly inside of Emacs.
What we'll do here is demonstrate how you can set up a Git Bash shell specifically to run Git commands and do any of your version control right from Emacs too.
Right, let's set up a Git Bash shell within Emacs, so then we can execute Git commands directly from Emacs. So we'll put it down here. The first thing we want to do is there is a variable that gets used by Git Bash and shells in general. It's the explicit bash, and it's whatever name it is, whatever the executable is, and the args. And we want to say login, which will load our bash profile, etc. And we want it interactive, so we can communicate directly with it. Okay. So then we'll do a new function. Git bash, no parameters. Let's put a doc string. Run git bash in shell mode. And interactive. And now we want to define the shell name, where it's located. And I just know off the top of my head what it is. So that's in the program files git bin bash. That's where that gets set up. But we want to use variable, so substitute file name. We have program files git bin bash exe. And the expand file name will convert the backslash into / for us. And close off that let parameter. Let's give the universal argument and launch the shell. So I'll save that, evaluate, and things worked out. We call Git Bash from here. It launches a shell. Now you can run your Git commands all from here. One thing that this does is it will open up in a new window every time. If you don't want that functionality, you can edit the display buffer A-list. Display buffer A-list. And I've already done this, so it'll be in here. And what I want is to reuse that window if it has already been created for me. Otherwise, it'll make a new one. So if you hit enter on the menu, here's the available choices on what you can do to the display buffer A list and how it behaves. You'll notice in here that we have the CM and compilation buffers that have their own function that gets run when the CM buffer is requested to be shown. A pretty quick and easy way to get a Git Bash set up. Now, as the login does, it uses the bash profile to run the particular environment. It'll throw in some garbage by default when it prints into the prompt. If you wanted to clean that up, you can add this into the bash profile and it won't look as bad.
Thanks so much for attending and listening to me prattle on about Emacs and what I find interesting and cool. You can contact me at my email address here if you have any further questions, and I will do my best to respond to them. Thanks again, and I hope you enjoy the rest of the experience.